Alright, in this video we're going to talk about quadratic functions. Quadratic functions, remember, are our U-shaped functions here. If I look on a graph, I will see that is a U shape, either facing upwards or facing downwards. Alright? Now that's what it looks like in a graph. In an equation, our function, if it's quadratic, has to have that squared piece. For instance, our parent function for a quadratic is y equals x squared. Now, we could also see quadratics, remember, if the equation is like this, where it has parentheses plus 2, for example, x plus 2 squared. You could also see it where it has x squared plus 3x plus 9 is another example. Key piece is that you must have a squared term, and you cannot have any exponents higher than 2. You get into the 3s, 4s, 5s, you're getting into other functions, not a quadratic. We stay with just the 2's in the quadratics. Alright, so that's our parent function there. Let's take a look at x-intercepts. Now remember, with quadratics you can have 0 x-intercepts, 1 x-intercept, or 2 x-intercepts. It's still just like when we talked about linear, where it has to cross the x-axis if it's an x-intercept. Okay, your line, or in this case your curve, must touch the x-axis. If it touches it twice, you have to say both x-intercepts. If it touches it only once, you say that one coordinate. In this case, my U-shaped quadratic, my parabola, as we also call it, is not crossing the x-axis at all. So we're just going to put none. Y-intercept is the same as linear. It's the point where it crosses the y-axis. So let's take a look. If I go up, I see it's 7 where I'm crossing the y-axis. Again, we want to write this as a coordinate because this is a point. So my coordinate, my x value is 0, my y value is 7. Alright, next up is our vertex. Our vertex is either our highest or lowest point on our parabola. So in this case, I see my U shape, and the lowest point here in this case, in other words, my minimum, is this point right here. So my x value is 3, my y value is 1. Again, the vertex is a point, so we want to write it as a coordinate. And we said the x value is 3 and the y value is 1. Now remember, your vertex is very important because it helps you come up with a few things. One of those things is your axis of symmetry. Now your axis of symmetry is that dotted line here that goes through your vertex. Alright, it cuts your parabola in half. Alright, so right here is where my axis of symmetry is. And we write this as an equation. The equation is going to be x equals whatever my x value is in my vertex, which in this case it's 3. Again, the reasoning for this is if I go along this line here, I will see all x values on this line here. All the coordinates have an x value of 3. Alright, let's move on to domain. Domain, remember, is all the possible x values I have. So if I go to the left, is there a stopping point? No, I see an arrow. If I go all the way to the right of my line, is there a stopping point? Nope, I see an arrow. In both cases, there are arrows, so that tells me I have my line is continuing on forever and ever in both directions, which means we have all real numbers here for our range. For our domain. Sorry, I meant domain. Now, when we're talking about range, on the other hand, that's all of our possible y values. So, if I take a look here, I'm looking for my low and high point. My low value, I actually do have a low value in this case. My lowest y value is 1. Never at all on this parabola will my line go below the number 1. Now, on the other hand, going up, I have that arrow telling me I'm continuing. If I go in the other direction, I have that arrow going up saying I'm continuing. So let's go ahead, let's put in our range. We're going to have to write this in our inequality notation. We start out with our low point, which we said is 1. And we can be less than, we can be greater than or equal to, so we want, give me a sec here, I gotta find that sign, there it is. We want to say that y has to be greater than or equal to 1. In other words, it's that opening has to be facing the y. So you could write it like this, or you could have also wrote it like this. Y is greater than or equal to 1. Both ways to write it are exactly the same. Both cases we have greater than or equal to. The opening is facing the y. That's the key thing. Alright, now we didn't go ahead and put in our table. Let's go ahead and do that now. For our table, we just need to put in a few points. So let's put in 0, 7. Then we will put in another coordinate that we see here. Remember, you always want to pick clean points. So while this right here looks like it's a clean point on our graph, it's actually not hitting that intersection of our grid lines. We don't want to use that point. But we will use our vertex of 3, 1. And then I keep going. No, not yet. Right there, we got 6, 7. And that actually makes sense, because if we take a look here, notice the y values are exactly the same. Our vertex is sandwiched in between them, which is what we talked about when we talk about quadratic functions. That's how you know from a table that you have a quadratic. You have the vertex and you have repeating y values. Alright, so that's your review on quadratic functions. We got one more video left on exponentials.